Alright, today we are doing 0-2 operations with complex numbers. Hopefully today will be a lot of review material. Today's date is today. Our objective: perform operations with pure imaginary numbers and complex numbers, and use complex conjugates to write quotients of complex numbers in standard form. That's a fancy way of saying rationalize the denominator. So there's your joke for the day. Because the square root of -1 is a complex number. It is imaginary. See, it's complex. All right, so we start off. That is just going to be I. If you had the square root of -1 squared, that would be I squared. And what happens is that'd be -1 times -1, which would be I squared. The negative sign and that cancel. This is going to be an important one to remember for later on, that I squared is the same thing as -1. All right, so if I asked you, though, to get the square root of -100, well, that's the same as the square root of -1 times 100. Well, the square root of -1 is going to give you the I. The square root of 100 is 10. And we usually put the I after the number, so that would just be 10I. The square root of -48, well, that's going to be the square root of -1 times, I'm going to think of that as 3 times 16, trying to think of what perfect squares are divisible into 48. And that is, well, the square root of 16 is 4. The square root of -1 is I. And I can't do anything with that radical 3. So it's going to have to stay underneath the radical. So 4I radical 3. And that one would just be 6I. All right. When we combine real and imaginary numbers, it's called complex. And we've actually always dealt with complex. It's just that the real part was what we focused on, the imaginary part was 0. When we are simplifying by adding and subtracting, all you're going to do is combine like terms. Combine the real parts, combine the imaginary parts. 9 plus 2, 11. 6I minus I, 5I. And that's as far as I can go there, so I'm going to stop right there. That's my answer. When I'm subtracting, I always like to distribute that negative sign, so I change that to a plus and change the sign of everything inside. I just have found that that's an easier way to deal with it so that you don't have to worry about making mistakes with your signs. So there is no real part here. I'm just going to write -3. You could think of that as 0 plus -3. And then -12I plus -3I. Oops, I wrote a plus sign. Should have waited just a second. And actually, I should have written a minus sign. Oops, and my pen got a little thicker. Well, one thing that I forgot to mention too is when you're writing complex numbers, you always want the real part to come first and then the imaginary after that. All right, on this one, we have multiplication. You're just going to take and distribute, just like you normally would with the distributive property. -2I times 5 is going to give you -10I. -2I times 4I is going to give you -8 I squared. And then we have to think back. What does I squared equal again? We talked about this at the very beginning. I squared is really negative 1. So negative 8 times negative 1 is going to give me positive 8. And then I've got that minus 10i. And again, I like to have the real part come first. On this one, you're going to FOIL. First, outer, inner, last. So 2 times 2, 2 times I, negative I times 2, negative I times I. What's kind of nice on this is those middle terms cancel out. So you have 4 minus I squared, which would really be 4 minus negative 1, which would be 5. You might remember this from Algebra 2. Those are called conjugates. Conjugates just have different signs in between the two terms. One will have a minus, one will have a plus. The main thing you need to remember with the conjugate is when you multiply it, if you've done everything correctly, you will have a real number as your answer. Multiplying two conjugates will always give you a real number. And why do we need to know that? So that we can rationalize. Because that I is really a radical sign. I can't have a radical in the denominator. So on this one, I'm going to multiply that by negative I over negative I. Some people go ahead and multiply it by negative 7i over negative 7i, and that's perfectly fine because that's what its conjugate really is. I've just found out that it's easier to do just the I over the I sometimes because that way you don't have to simplify or reduce your fraction at the end. So this is going to give me, on the bottom, I'm going to have negative 7i squared, and at the top I'm going to have negative 5i minus 4i squared. And I don't really like the way that looks because we can make that look a lot better. Negative 7 times negative 1 would give you positive 7. Negative 4 times negative 1 gives you positive 4. And then you've got your minus 5i. And I'm going to separate this up into so it looks like a complex number. That would actually be 4 sevenths. That would be my real part. And then my imaginary part is going to be minus 5 sevenths over or times I. So that's right here is what my final answer really should look like. This one, a little bit more complicated because you've got a binomial in the denominator. Same process, you multiply by that conjugate, which is going to be 2 plus 3i. Oh, that 2 went a little crazy there. Let's try that again. Okay, and you're just going to FOIL the bottom and the... So I went ahead and I FOILed these. Those cancel on the bottom, the 6 i's. That'll actually be 4 minus 9 times negative 1. So 4 plus 9, which is going to give me 13. And on the top, that negative 18 times negative 1 is going to be positive 18. Plus 4 gives me 22. 6i minus 12i minus 6i. And then we're going to split those guys up. So 22 over 13 minus 6 over 13 I. So, why do we need to know complex numbers, imaginary numbers? They're going to come up from time to time when we're solving equations and we need a way to deal with them. So I'm going to solve this just like I would any other quadratic. Subtract 50 from both sides. Divide by 2. Take the square root. Square root of negative 25 is going to be plus or minus 5i. We have to write that plus or minus in front of it because we are dealing with solving and we don't know whether it's positive 5i or negative 5i. All right, that's all I have for you today. Hope you enjoyed.